So today we will solve this to some second problem. So the input array is sorted. So the problem description is we have given an array under target, array of integers under target integer. So what you have to return is we have to return the index. We have to add to each two digit, and if it is equal to the target sum now, if you take any two digit, and if you sum, and if it is equal to the target sum now, we have to return those indexes. Okay, for example here, right, the target is 9. Okay, so 2 and 7, if you add 2 and 7, it is equal to target sum. Okay, so we have to return the corresponding indexes. Okay, so it is one based indexes. Okay, for which means index is starting at 1, not 0. Okay, so we have to return 1 comma 2. Okay, so there must be one solution, so we don't worry about any other worst the cases which is not present. Okay, there must be only one solution. Okay, uh, so so basically we can solve this problem using two pointer approach. So how we can solve is, since the input array is sorted, right, uh, what we can do is we can use two pointers. Okay, let's take start pointer will be 0, and then end pointer will be pointing to last element of the array. Okay, last element, how we can take last element? Len of array, len of numbers minus 1. Okay, so we can run a loop until s less than e. Okay, so first condition, what we can check, we can add these two numbers. Okay, starting index and ending index, and we can take these values and we can add. If it is equal to the target sum now, we can return those indexes. We can return s and e indexes. Okay, before returning we have to return uh, plus 1, s plus 1 and e plus 1, because it is one base indexes, right? So we have to return by adding it 1. Okay, we have to return in an array. Okay, okay, so suppose in this case it is not matching, right? Then what you have to check is, if you are adding, so 2 plus 15, which is 17. So 17 is greater than target. Okay, so what you have to do, it is greater than target, so we have to remove this last element. Okay, and we have to check with these numbers. Okay, if it is greater now, we have to decrement the end pointer by 1. Okay, so now we can move the end pointer here. Okay, so now the end pointer is here, and start pointer will be pointing to the initial value, the first index. Okay, since the here start point is here, and again we'll try to add these things. Now 2 plus 11, which is 13. Again 13 is greater than 9, so what do you have to do? We have to decrement the end pointer. Okay, so now the end pointer is here pointing to 7, and start pointing is at 2 only. Now we will add 2 plus 7, which is equal to target sum. Okay, which is equal to target sum, so we can return those indexes. Okay, so if it is lesser now, suppose let's take here some other value. Okay, if it is lesser than the target sum now, what you have to do? We have to increment the start pointer. Okay, again we have to do same thing. Okay, so first we'll solve this solution using loops, and then we'll solve using recursion also. Okay, so we are getting two inputs. One is a array and another is a target value. Okay, first let's take pointer. Starting pointer will be 0, and then ending pointer will be len of numbers minus 1. Okay, so we have to run a loop until s less than e. Okay, first base condition, like if numbers of s plus numbers of e. So if it is equal to target sum now, target, it is equal to the target now, we have to return an array. Okay, array, it is one base index. Okay, so what you have to do? We have to increment the index by 1. and e plus 1. Okay, suppose if numbers of s plus numbers of e, if it is greater than target, now what, if it is greater than target, now we have to decrement the n counter by 1, e counter by 1. Okay, so e will be e minus or equal to 1. Suppose if this two sum is lesser than the target, now we have to increment the starting pointer. Okay, yes plus or equal to 1. Okay, so I think that's all, because there must be only one solution, so we don't worry about when the solution was not there, there'll be exactly one solution, minimum one solution will be there, so it will be returned. Okay, so we'll try to run this one. It is paused. Okay, so now it is paused. Okay, we have done using loops. Now let's try to write the same logic using recursion. Okay, so the same thing we are going to do it in recursion. Okay, so let me remove this one. Okay, so we are going to use the same logic, so there will be starting pointer and ending pointer, and I'm going to have some separate function. We can name it as if helper function, which accepts starting index and ending pointer, which accepts two pointer. So since numbers and target is common for this function also, it is global. Okay, so it is helper is inside two sum function, so helper can access the numbers array and target array, so we don't need to pass the numbers and target again. Okay, so first base condition will be like same, if numbers of s plus numbers of e, if it is equal to target, it is equal to the target, now you have to return an array, right? Return s plus 1 comma e plus 1. If numbers of s plus numbers of e, if it is greater than target, we have to decrement the end pointer by 1. Okay, so what you do, we have to call the function, helper function. Okay, and s will be same and e will be e minus 1. Okay, suppose if the two sum is lesser, now we have to increment the starting pointer, else we have to call the same function helper, and then which is s plus 1 comma e. Okay, so think that's all. Now we have to call this helper function. Okay, we have to pass initial values, so initial value will be 0 and last index of our numbers. Helper, we have to return this function, correct? Whatever helper is returning, we have to return to where we are calling this to some function, so that's why I have to return helper. We have to call with s and e. Okay, so now let's try to run this one. Okay, it is paused. Now let's try to submit it. Okay, it is paused. So now there is some only one exactly one solution is there. Suppose let's assume that it does not have one, it does not have any solution. Suppose if no solution was there, means what you have to do, same thing slightly, what you have to do, the function has to return array. Okay, if the element was not there, if the two sum was not there, now we have to return array with -1. Okay, now let's try to add this one also. If s is greater than e, if s is greater than e, now what we can do, we can return an array with -1 -1. Okay, so we can, for this problem it is not needed. I'm telling for the problem, suppose if the exact solution was not there. Okay, for that one we can add this condition. Okay, for this problem we don't need. Okay, now let's see how recursion works. Okay, so first initially we have declared a s and e pointer, and then where the execution it comes here. Okay, we are calling it's just a function definition. Okay, so we are calling this helper function, and what we are passing initially, we are passing 0 and what is the length of numbers. So initially let's take this example. Initially it will be 1 2 3 4, so length is 4, 4 minus 1 which is 3. So initially we are passing 0 comma 3. Okay, so here we are passing 0 comma 3. So starting s will be 0 and e will be 3. So first assume that we are calling this function, so we are calling helper function, so this will be called index 0 comma 3. Okay, and we are checking. Okay, let's copy this array so that you can see here. Okay, let me put here, this is the array and this is the numbers. Okay, so first we are calling with 0 comma 3. Okay, and we are checking numbers of s. What is numbers of s? 2 plus numbers of e. Numbers of e will be 15. Okay, 2 plus 15 will be 17. If it is equal to target, target is 9, not right. So now what will happen? Now we are coming here and we are checking here numbers of s plus numbers of e, which is 17 greater than target. Okay, which is true, then it will come here. What we are doing, we are calling helper function. Okay, with e minus 1. Okay, we are just decrementing e by 1 and we are calling the same function. Okay, s remain as it is same and we are just decrementing e minus 1. So now again the same helper function will be called. Okay, for your reference I wrote separately. Okay, so now this function will be called with 0 comma, what is e now? E is 2 because we have decremented it by 1. Okay, e is 2. Again we are checking numbers of s. What is numbers of s? 2. What is numbers of 2? 11. Okay, 2 plus 11 which will be 13. So 13 which is not equal to target, then it will come here, and 13 greater than target 9. Okay, again we are calling the function, and what we are doing, we are decrementing e by 1. What is e? 2. If we decrement by 1 now, 0 comma 1, we are calling the same function with 0 comma 1. Okay, so here we are calling. Okay, the same function will be called with 0 comma 1 and we are checking here. Okay, so numbers of s will be 2 and numbers of 1 will be 7. Okay, now it is equal to target, and what you are returning, we are returning s plus 1 and e plus 1 because it is one based index. So we have started with 0, so we have to, while returning we have to incrementing it by 1 and we have to return. Okay, so now where it will go, now we are returning it, right? Where the return this value will go. Okay, previously where we have called this function, that place it will go, this array will go to previously where we are called. Okay, previously where we are called here. Okay, we are called here, so this array will come here. Whatever we are returning here, right, this will come here, and this function where we are called, from here we have called it, this function. Okay, so that is why we are putting here return. Okay, this return will go to previously where we are called. Okay, so previously we are called here. Okay, so array will come here, and this function where we are called here. Okay, so the array will come here. Okay, after that this return will, where will go, in the outer function. Okay, this all in some outer function, if outer. Okay, so let's assume that, so this is some outer function. Okay, which has numbers and target. okay, and we are calling the function here outer, okay, which is numbers and target. Okay, so these 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 statements are inside this outer function. Okay, so where the last where it will come the returned value at last will come here. Okay, so this is how recursion works. I hope you understand.